I've started converting all my routines into this new development environment. So here we are. This is the code for the extended basic routines that I wrote, and the extended basic is that that you can do line renumbering in basic and other things. And as you can see, I have actually started converting these programs. I've managed to get them off my floppy disks, and then I've used the CBM Prg Studio to import it in and start converting it into this assembler rather than the assembler that I wrote myself. And some of them are actually working. I think this one works, so let's try it. Let's see if it works. Please bear with me if it doesn't work, and I don't think it's working. I think we've got some errors, and sure enough, we've got an error. So it's saying can't find that. So I've missed that out. So I know where it is. So let me see if I can find it. And it's that one there. There we go. Give that a save. Send it on its way. There we go. So far no errors. Not that I can see. Oh, and there we go. Got some more errors. So as you can see, I'm still in the middle of converting this. So, but I have got some other ones. So let me just close that down, and I'll grab another one. Right, this is my Sprite Editor, and I don't think this one is converted. But you can have a look, and no, it's not converted. I can tell that from here. There's some. See these here. These need to be sorted out. So I've managed to load it in, and into the studio, but I need to convert it to work with the new assembler in the studio. So this is the Sprite Editor that I wrote when I was a teenager, because I didn't want to pay money for a program. So I wrote my own Sprite Editor. Same with the extended basic. That was the programmer's aid system that you could buy. Now here this is my assembler. So this is the assembler program that I wrote to assemble my assembler. Now this assembler program was originally written on a VIC-20, and I used the Commodore VIC-20 machine code monitor to write it. And then when I'd wrote it, I could start writing assembly. And so the first thing I did was I wrote the assembler that I'd written in the machine code monitor in assembly, and then assembled the assembler, if you know what I mean. And this is the assembler and all its code, and this is converted. I'm just having to comment it. I'm going to start commenting it, and these are the things I'm going to be showing in future episodes, future videos, because these are interesting code that I think you guys will be interested in, and eventually they will be going on GitHub, so you will be able to download them for yourselves and have a look. So here we are. So if I run this should work, which it is, because I've converted it. So I'm going to load it up into the emulator. So here we are. So it's loaded up, and it loads itself into C000 memory space. So it's well out of the way of a computer, the Commodore basic program. So we can start writing. So what we're going to do is, and now the way my assembler works is you have to put a quotes into the line, so it then records when you're in the basic program. It will store the commands as is. So we tell it where to start. So I'm going to get it to start at 4,000. Now, no, 8,000, it's easy to remember. And then 20, so I'm going to load the accumulator with hash, there it is, with let's see, $31. So that should be character 1, and we'll store it in the top corner of the screen. And then 40, we will return back to basic. So there's a small machine code assembly program written in the using the Commodore BASIC environment, and then what we do is we fire the assembler. So 49152, go. So it assembles it, and there we go. So it says it started at 80,000, which is 32768. Load 31, store it in 04, and then return. So if we do, and we'll move down a bit because it'll think. So SYS 32768. There you go. It's put the number 1 up here. And the beauty of this is we can change it like a normal program. So maybe, let's say I want to do I want to increase this, yeah. So we'll need to give it a label. So we'll call it screen. Whoops. Insert. Ooh, where's insert? Nah. So we'll give it screen, and then it's LDA $400. So here we have to do 35 increase screen plus 1 plus, where's plus? There we are, plus 1. So that's going to increase the screen, the location screen plus 1, which should be 0 0, yeah. And that's going to go round and 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 round. But what we're going to do is we're going to put 36 branch if not equal to screen. So hopefully that 49152. So we assemble it. Ooh, my label's too big. 1, 2, 3. Yeah, label's too big. So we'll call this SCR. Press enter. Move along here. SCR. Press enter. Move over here. Press enter. Right. 49152. Ooh. There we go. So it's put the 1 in. Now I need to get it to loop back round. So let's see if we can get it to loop back round. So 36 branch if not equal to SCR. Doesn't like the branch if not equal to. So I haven't fixed it. That's a shame, but that's all right. We can use that as a tutorial where it's not actually, what the problem is, it's not actually recognizing the branch if not equal to. Is it going to recognize anything else? So if I branch if minus, see if it's all the branch codes. Yeah. That's disappointing. But what I can do is I can load my assembler. So if I do this, then load, right. Right, so there's my assembler for 6, so it's load 02. To star. Where's star? There we go. Comment 8 on 1. New. Try again. SYS 4917. Yeah, right. Star equals. Oh, equals. Where's equals? There we go. Cool. Typing's getting better. str $400 40 ink scr +1 50 branch of knock equal scr 60 RTS 7 overrunning assembler error. Really? Oh yeah. Oh yeah. Blank. 8. There we go. See, it's done it now. Branch not equal. So, as you can see, not scripted. It's off the cuff. So my original assembler that I wrote as a child works, but my conversion still has problems, so I've got to sort that out. So if I SYS 32768 and we'll move down, it should increment it. There you go. So it's incremented and put 1s in. So do it again. There you go. So this is my assembler inside, and see, some Commodore 64 assemblers, you had to run their program and then you entered it as it. Here I wrote it that it was part of BASIC. So when you saved it, you just went save JCD test, comment 8, done. And then that was on the disk. There you know, JCD test. And then you would load it back in. So I will, so just to show, let me fire this back up and see if it, just in case I corrupted the assembler to start with. So I've loaded it up, do new, we'll load my image up and then do JCD test, comment 8, list, SYS 49152. Yeah. So there's definitely a problem on when it's trying to detect the branching. So that we'll have to I'll have to look find out why the branching is failing. But that's the assembler, yeah. So and I've got other programs that I've written. So here we go. This is the character editor, and this is where we could define your own custom character set. And this is working as far as I know. I've done the conversion. Haven't ran it yet. So this is at 9,000. So SYS 9 times by 496. There we go. So do I want to keep the characters? No, because I want to mask it. Yes, I do want to mask it with set naught, block naught. This display allows you to put, I'm going to put an 8x8. It allows you to have an 8x8 character, and here we go. So that's the character note. Next, next. I think it's previous. No, back. No. Oh, that's up down. So there are lots of commands, and I've forgotten. So that's to do a horizontal flip. Let's see what other commands we got in here. So MRWG. So what's M? Oh, mask. Well, note. Oh no, like a plank. Twice. 9 times 496. Yes. 8 right. Right, so B's that. What's V? V's M. Mask 0, 0. Yeah, that's brought it back. Oh, cool, it's been a while since I've used this. So I, what's I? I. Oh. So that's doing an invert. What else we got? T. What's T? Oh, rotate. So this is working. So next, back, next, previous, back. What's next? Previous, no. Don't know what back is. Cursor right, no, home. So what's next and back? Word back is next and next. Ah. Arrow, what's that? Oh, there we go, back. So as you can see. Anyway, so that's the character set generator that I wrote as a kid, so I could create my own characters. We'll close that down, and I've got other. So this is the machine code monitor. So this should be working. Need to comment it, and this is starting at 9,000 as well. So let's just do that. SYS 9*4096. There we go, and this allows us to assemble, disassemble. So we could disassemble, say 93. So if we do disassemble 930A to 9400, there you go. So that's doing the disassembling of that. Now there's lots of question marks in there. So what I'll do is I'll disassemble 9000 to 9010. Because that's where the jump is, and then it just says jump 9 to FE. So we'll disassemble 9 to F7 to 9300. There you go. So in fact 9350. So it's disassembling the memory, and we can do the memory of it as well. So 9100. So that gives you the memory. You can look at the ASCII characters, 910. And there's a whole rack of other commands that we can do. So we can fill, transfer, and this is another program that we'll be going through and trying to make better, and that will be going on GitHub as well. And I've got some more program. So here's a basic program, and this is what I used to use to control my finances. It's got some machine code in it because that's what these data lines are for. So it does a mixture of machine code and basic. It talks to the disk drive in relative mode, so we'll be going through that as well, because I will be doing some tutorials on basic and getting into that, and also doing the same tutorials in machine language, so you can do a comparison. So we'll be talking about that, and then as well, this is a program called Maze, and what this does is it's a game that auto generates a maze for you. Now I am converting this, so the instructions there are: first enter the length and width, blah blah blah, good luck. So I'm going to say 20 by 20, and it's going to generate a 20 by 20 maze. And as you can see, it's generating it in front, and then what we have to do is get through it as fast as possible. And I've forgotten the keys. Oh no, forgotten the keys. Oh, that's not a good sign, is it? I'll tell you what, let's fire it again and read the instructions, because I forgot what the keys are. Yes. Right, AZ, left and right, got ya. 20 by 20. Right then. And we're away. That's a dead end. Oh, am I on a winner? Am I on a winner? Oh, come on. Come on. Yay! So we can make it as big as possible. 39. I was really chuffed when I got this to work, because every time you run it you get a different maze, because it randomly creates the maze and then checks it. That's what the red is. It's checking that there's no thing. There we go. So we're off again. And what I want to do, and I think I've done a video about this already, what I want to do is, instead of having a block, I want a little man, and also want to be able to, that after a certain, oh, that's gone the wrong way, I'm in a dead end. After a certain amount of time, I want baddies come chasing you, so you have to escape the baddies as well as trying to find your way through. And this is where hopefully that, you know, we could make this a lot better than just a boring old purple block going around the screen. And all like I say, all these programs that I've written will go onto GitHub as and when we start doing the videos about it. And I'm always open to people telling me if I'm a good coder or I'm a bad coder, because that's the only way we learn. Because no one person, oh, crikey, no one coder knows everything, and this is how we, as well for me especially anyway, I always want to learn new stuff. So, and I've been looking at other people's code. Crikey, this is a difficult one. It's a bit difficult trying to concentrate and talk at the same time, but I look at other people's code and I've learnt a lot from other people's code as well, because I think, oh, that's a different way of doing it, and then look at doing it myself. Wow, 1 minute 25. Anyway, so I'm going to be doing videos about all my source code once I've converted it, but I'll also be doing videos about other people's source code. So here we go with Grey Defender. He's got a YouTube channel, and he made a series of videos where he made a childhood game, the Pac-Man, and he made a Pac clone, and ultimately he converted it in and created the Dimension Defender, which is this program here. And as I'm scrolling through it, this is all his code, And what I will do is we're going to break his code down into segments and just run through it and understand how it worked. And we can start it up. Oh, got an error. Invalid. Oh. Reset. Reset common bars. Oh, it's not there. Oh, what's if I'm finding the right one? That's better. This will come on. Maybe the last one is not quite. He's doing something. But here we go. So press anything. F1 for options, or press to play. Now. I'm rubbish at this game. And the problem is I've played this game so long. Here we go. And it's a great game. Smooth. Whoa! That was lucky. Smooth movement. And so we're going to look at that at Glenn's Pac-Man and understand how he's written the code. I've also got this called Breakout, which is by Darren DeVol, and this has been in production with Commodore 64 Brain and his team, where they was trying to build a game, and unfortunately some of the people went the different ways, and so this is where he finished it off, and it's a very good game. So if I run it, right, I need the joystick. Right, press fire. I think that's control. I've got the joystick set. Let's have a look. Do that. There we go. It's getting itself confused. And we'll do the same with this as well. So we're going to go through the code of this, and so we can compare programming styles between two different programmers. And I'll put, when we do the code, I'll put a link to the code, because I don't want to put the code in my GitHub, because the code belongs to those guys. But it'll be interesting to see how they do things and how it works. Now, I've just noticed that this video is going to be 45 minutes long, so I will say tatty bye for now, and see you later. Take care. Bye.